Hello friends, welcome to this tutorial where we are going to discuss about solid design principles. So this is going to be a series of videos where we'll be discussing about all the five design principles. But in this particular video, we'll be discussing a bit about solid design principle, and then we'll cover the first principle, that is single responsibility principle. So let's start with the definition and benefits of solid design principle. Its definition says in software engineering, SOLID is an acronym for five design principles intended to make object-oriented design more readable, understandable, flexible, and maintainable. Okay. So, the key thing over here is it's an acronym. So we have five design principles. Okay. So this is an acronym. If you see this word solid contains five alphabets, five characters, right? So each of these alphabets refers to one design principle. That's why it's an acronym. And why we use or why we should use this solid design principle, because it gives you these benefits, right? The code will be more readable, understandable, flexible, and maintainable. So let's move to next slide. As I said you that this is an acronym and each alphabet represents the principle. So S represents single responsibility principle. O stands for open closed principle. L for list for substitution principle. I for interface segregation principle. And last P stands for dependency conversion principle. So we'll be covering all these design principles in this series of tutorial, but in this tutorial, I'm going to talk about the first one, that is single responsibility principle. Let's move to the next slide and see the definition of what is single responsibility principle. Single responsibility principle states that class would have only one reason to change. And in other words, a class or a method should be responsible for doing only one thing, and it should do that one thing really well. So don't worry if you know if these statements sound a bit difficult to you. And I'm sure by the end of this video, you guys will fully understand what is single responsibility principle. So please bear with me. So to understand it better, I'll give you some real world example, and then I'll demonstrate it through some code also. So if you take an example of something, suppose some event is going to happen in your house, okay, or something like a marriage or something, and you are giving all the responsibilities to just one person or couple of persons, say arrangement of tents, arrangement of catering, shopping, all these activities. So for now, let's take these three activities only, okay? Shopping, um, catering, and tents. So you've given all these activities, arrangements to one person. So if suppose there is a change in any of these activities, whether it is shopping or tent or catering, you will go to the same person. Means you don't have a specific reason to go back to that particular person. So what happens in software engineering, you usually write a code, a piece of code, and maybe in future you do it happens quite often. You do some refactoring due to some defect came, or some new requirement came, or you want to improvise your code, you do code refactoring. So you come back to the class or method that you already have written. So ideally you should have a specific reason to come back to that particular class. Okay? So that can be achieved if your class or method is doing only one thing. As I was talking about that example, you given these three responsibilities to one person. So you don't have a specific reason to go back to that person. You have lots of different reasons. Like even if there is a change in shopping, you will go to that person. Even if there is change in tent or catering, you will go to the same person. Means you have assigned multiple jobs to one person. So the drawback of this thing is the chances of mistakes or committing mistakes is higher over here. The same person is doing the same multiple things. They can commit he can commit a mistake, right? Because everyone is having a capacity of doing something. The same thing applies for your programs as well, or your software components as well. So, and I'll give you some examples also. After that, it should be more clear to you. So let's see one example. Now, if you see, I have written a class called invoice. Don't 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 look into the logic or business logic. I have not provided the whole implementation. It's just a high level design kind of thing that I have written just to explain you guys the concept of single responsibility. So this is a class called invoice. We have three methods in this invoice, the invoice class, that is calculate total, store invoice details, and print invoice. So these three activity is being done by just one class. And if you see, calculate total is okay, then it's fine, because this calculating total is should be a job of invoice, because invoice is really related to the items and calculating data totals and all. But if you see these two activities, these are not really associated with invoice. It's storing something to the database should be a persistence layer or the repository layer, right? And similarly, printing something should belong to a representation layer. It should not belong to invoice. Although you are printing and in storing invoice, but the core logic is to, if you are storing something, you will be writing some database logic over there, right? And if you are printing something, then in that case also you're writing something that is not related to invoice. So in this case, if suppose there is a change, if suppose you are initially you used app MySQL as your database, and in future you are trying to replace MySQL with Oracle, you will have to come back to this invoice class, because you have written the logic of storing the database over here in this method. So although that database related things are not related to invoice, even then in that case you are coming back to this class. That is not a good thing. You don't have a specific reason to come back to this class. You have lots of different reasons. Even if there is a change in printing logic, you will come back to this class. So this should not happen. This is not following the single responsibility principle, this particular class. So let's refactor this class and try to achieve single responsibility principle. Okay. So I already have written a couple of classes into this. So if I have refactored this class, this is a new invoice class. So as I show you in that slide that a class or method should be responsible for doing only one thing, right? So now if you see, this invoice class is doing only one thing, that is calculate total, right? And similarly, I have written two interfaces, one for storing the invoice to the database, and another is for printing. So because these are interfaces, you can have multiple implementation classes of these interfaces, right? So you can have, different invoice printer implementation for different format of files. Okay. So now if you see all these classes are responsible for doing only one thing. So suppose if there is a change required, you have a specific reason to come back to this particular class. Only if there is a change in calculating total, then only you will come back to that class. If there is a change in database logic, then you will not go back to the invoice class. You will come to this invoice repository, right? The implementation classes of this particular interface. Similarly, if there is a change in the printing logic, then you will come to this particular interface or the classes that implements this interface. So now this all these three classes following the single responsibility principle because it's doing the single thing. Now you have now these classes have only one reason to change. Okay. So this was about class, but these principles apply for not just for classes. This is applicable for different components of a software application. Okay? It can be a class or it can be a method, it can be a package. So we talked about class, and let's see one more example for method. Okay, so suppose we have a class called weather, and the responsibility of this class is to give you weather information. Sorry, to store the weather information into the database. Okay. So if you see, I have highlighted in the comment, if you see, this is also doing three things. Activity one is getting the weather data from external API. So it's calling using you see this web service dot get data. So it's calling a third an external API to get the weather information. Of the first activity is to get the weather information from some external API. And then in second activity, it is validating the response, whether the response is having any error. Or if there is an error, then it's returning this illegal argument exception. Similarly, it is doing activity that is about persisting the data to the database. So if you see, I have written its insert query and then using prepared statement, we're trying to store this information into the database. So this is just a high level design. Okay, so just ignore these errors. I have not written the whole logic. Just this is just a high level to explain you the single responsibility principle. So this particular method is doing three things, three activities. So again, this is breaking or not following the principle of single responsibility. So let's try to refactoring. So I already have done this. I have written a new class. And if you see, what you can do is you can just move all these activities to separate private methods. As you can see, I have written a private method to fetch weather details. Similarly, I have another private method that is about validate weather details. It's validating the response that we got from the third party API or external API. Similarly, I have another private method that is responsible for persisting the response to the database. Okay? And then I have this. I forgot to write the method, so this is again a method. So 1, 2, 3. See, this is the first method. Okay? This is private method that I'm calling this second. And this is third. All these are doing different things. And again, this fourth method. This is fourth method. And this is responsible to orchestrate all the activities. Okay. Now I replace this old method to refactor so that it should follow single responsibility principle. So I divided all these three activities I just move all these activities into separate private methods. And now this particular method is responsible for orchestrating the things, calling all these three private methods. So this is called uh, single responsibility principle. This is the first principle that belongs to the solid design principles. And the benefit of this principle is if you follow this principle, your code will be flexible, maintainable, understandable. Anybody can read your code and understand easily. Okay. So I think that's it for single responsibility principle. In coming videos, I will be talking about other principles like open, closed list or substitution principles and all. So thank you guys for your time. Thank you very much. Bye-bye.